I will check and then thank you so much. Just give me 1 second.
You guys at home, let's stand for a word of prayer in class. Up you go, a little stretch, folks. Up you go, a little stretch. Little stretch, little stretch. Oh, this feels good. Get some blood flowing. Come on, Mr. Ross, Mr. Sanchez. Taking care of your body and your spirit is as important as your brain. So that's why we take a moment to do that. Okay, inhale. Deep breath, hold. And birthday candle. Ready? Inhale. Hold. Exhale. Stand there with your eyes closed for about 3 seconds. Deep breath, open your eyes. Okay, the reason why you close your eyes, folks, when standing with your eyes closed, be alert, but be calm. Because like in the ancient wild, you would never stand anywhere with your eyes closed unless you were 100% safe, right? Just so that's why the brain that interprets that is calm down, but be alert. That's why we do that. Okay, folks, all together, let's pray. Nope, we're praying. I'm sorry, you just got a physiological lecture, but let's talk to God. Ready? Sovereign Lord, help me for your name's sake, out of the goodness of your love. Deliver me. Amen. Your homework tonight, guys, is just your next preview note. So it's preview note 8.2, part 1. Of course, we're doing in class today, 8.1, part 2. Go to your reference booklet. We're going to do a recap of the preview notes. Be prepared for me to pester you guys because I'm going to be landing on almost 24 of you. And if you're like, but Miss Way, I don't know, you simply say, Miss Way, I don't know. And then I kind of walk you through it. And that's totally okay. Do not be embarrassed. There's a multitude of times in my various classes in life that I did not know, and that's perfectly okay. Come up here. We're in your reference booklet, folks. This is the first page of Unit 8. Start drawing the height of these triangles. So last class, we learned in an acute triangle, the height was inside. In an obtuse triangle, the height was outside. And in a right triangle, the height was on. So we have 3 different heights. 3 different heights. Lauren, what was the equation for area of a triangle, ma'am?
I think that it's base times height over 2.
You are correct. So let's kind of squiggle our bases. There's our base. Times height over 2. You're correct about that. This one, the base is just here. Times the height over 2. Now in a right triangle, things get a little weird because there's our height and there is our base. So the base and the height, Devin, is actually the what of that right triangle? That's correct. So this is the version for right triangles I prefer you to use. I prefer you to do one leg times the other leg. Leg 1 times leg 2 over 2. And the reason is that it's very common in like standardized testing. You're also going to see this when we do volume for that right triangle to be rotated. So a lot of you guys get lost where the base and the height is once you start rotating. So technically your base and your height would be right there, even if it's rotated. So that's why I prefer you to use the legs for right triangles. Now come down to your quad family tree. Jory, what's the area of a trapezoid, sir? Jory, a trapezoid's just a rectangle pushed sideways. That's it. Excuse me, a rectangle pushed sideways is a parallelogram. Jory, are you able to help us out? If you don't know, it's perfectly fine to unmute and say, I don't know, and I'll walk you through it. Kiddos, if your mics don't work, I need to have, well, one, you need to fix them. Two, you need to send me a chat and let me know. Okay, let's try this again. Jonathan, area of a parallelogram, please, sir. If you don't know, it's okay to say, I don't know. I'll talk you through it. Jonathan, if you're there, I need you to respond, please. Kelly, what is the area of a parallelogram?
Base times height.
That's it, because it's the same as a rectangle. Base times height, and height always creates a right angle. So a rectangle is also going to be base times height. Right here. You're going to want to have this filled out because you get to use it. So going this way, Zach, how are we going to find the area of a square, sir? Yeah, a square qualifies absolutely as a rectangle. So base and height works just fine. But McKenna, this side is the same for both. So what's another way I could say for a square? Or if this is side and side, what could I also say? Which would be? What would S times S end up being? Bingo. So for a square, we could just use side squared, of course. I want everyone please to draw in the diagonals for a rhombus and a kite. A rhombus and a kite. Draw on those diagonals. Sophia, what's in the middle here at both these diagonals? I have it in yellow. What's in the middle there? In yellow?
Right angle.
A right angle. That's super important. And the reason, because the diagonals are both perpendicular in a kite and a rhombus, that gets you the same equation, the exact same equation. So Ryan Worcester, what would be the area of a rhombus, sir?
I'm not sure.
Okay. Do you have your preview notes handy from last night's video?
No, I
Okay,
didn't have one.
Can you go grab those? Because I'll come back to you for another question. Jimmy, what's the area of a rhombus? Hudson, what's the area of a rhombus?
Base times height.
Not a rhombus, kiddo. It has to do with the diagonals because it's the same as a kite. What did we do to the diagonal, sir? Look in your preview notes there, Hudson. Jaden, what do we do with the diagonals for a rhombus and a kite? Kiddos, you might want to have your preview notes handy. You guys at home, you need to be ready to participate, okay? That's like 4 for 4. Stay with me. Mr. Sanchez, what do we need to do with the diagonals of a kite and a rhombus? What do? You do something to the diagonals. What do you do? It's really simple.
Is it diameter times diameter divided by 2?
Yes, it's technically we call diagonals. So yes, it is times, Mr. Sanchez. So diagonal times diagonal over 2 for both of them. And then this way diagonal times first diagonal times the second diagonal over 2. It's times, not plus. There's only one plus sign on this entire page, only one, and that's in the trapezoid. So in a trapezoid, technically, if you go like this, a trapezoid's 2 triangles, and a triangle is base times height over 2. But in a trapezoid, you have 2 different triangles. So the way you handle that is you average the bases. You got 2 different bases. So base 1 plus base 2 over 2. Then you times by the height. So this plus sign is the only plus sign on the entire page. Go to the first page of today's lesson, and we're going to do one problem together. First page of today's lesson. Looks like this, folks. You're going to go ahead and skip the first problem. Can you guys in class figure out why am I skipping the first problem? There's actually a typo there. Look really carefully. See if you can find it. What did I do wrong with the first problem? Yeah, I already put the base in there. I should have whited out the 41. Yeah, so I gave you the answer. We're going to focus down here, down here. Okay, Dylan, can you read this entire thing out loud for us, please? And try to fill in that blank. Go.
In the rhombus below, trace the diagonals. What kind of angle is in the middle? Trace the segment 10, trace x, find x. Find the length of both diagonals, then find the area of the rhombus.
Okay, so let's answer, Dylan, this first question. What kind of angle is right there? If this is a rhombus.
That's a right angle.
You are correct. Put your right angle there. Okay, now let's follow the instructions. The instructions tell us to trace the segment 10, which is from here to here. Trace it. Everyone trace it. You guys at home trace it. Trace it. Now, trace X, which is from here to here. There are 3 finds. You're going to find the length of both diagonals. You're going to find X first, then find the length of both diagonals, and then find the area. So there's 1, 2, 3 things you're going to find. I'm going to give you 3 minutes to do this on your own. Get as far as you can in 3 minutes to find those 3 things. Go. Yes, you can use calculators if you feel like you need them. If you touch a calculator, you must write down what you're calculating, friends. Go. So we are missing Jurian, Chloe, Mary Han. Get as far as you can on your own, folks. Did you find all 3 of them, Sophia? Remember, there's 3 finds. 1, 2, 3. Do you see it? Look at the word find. There's 3 of them.
Yeah, I think I did it.
Okay, fabulous. Then work on something on the right-hand side while you're waiting. So you're never wasting time. Yeah. I prefer you to use a calculator. Do you know how to use this TI-84 thing?
Yeah.
Okay. Use this then. You okay?
Yeah.
You gotta, good, good. Yeah, trace that again. Where else do you see exactly that? All right, friends, let's do this together. So we had 3 finds. So the first thing was finding X. McKenna, did you get that far?
I don't think I got it right.
Well, what was your thoughts?
9.
How did you find it? You're correct so far. 10 squared plus X squared equals 26 squared. Maybe that's where we kind of dropped it. Okay, so why don't you start working on that? Okay, Mr. Ross, what did you get for X? So we found our X is 24. Now it says find the length of both diagonals. So we're going to write out our rhombus area equation right here. Area equals. And hi there, Lauren, can you tell us what is the area equation for a rhombus, man? Just dictate it to us.
It's D1 times D2.
Diagonal 1 times diagonal 2 over.
Over 2.
Yes, ma'am. Okay, so when I do this, Lua, see the blue, Lua? When I trace that one diagonal, what's that length, the blue? Hi, Lua, you there, ma'am? Okay. Zach, what's our length of our blue? Yes, the length of our blue is 20. Edwin, what's the length of the red diagonal? 48 over 2. And then you just reduce, that goes in there 10 times. And Amelia, what did you get for the area, ma'am?
I didn't get that yet, but
Okay, that'd be great. Ten times 48, ma'am.
10 times 48.
Yes, ma'am.
Oh, that's 480.
There you go, 480 units squared. Okay, you guys in class, I want you to rotate and tell someone if you got this 100% right on your own, you just do a little boasting like, woohoo, I got it right. If you got hung up anywhere, I'd like you to tell someone, where did you get hung up? You guys at home, send me a text. If you got it 100% correct, send me some sort of celebratory, I'm so amazing, that was wonderful, 100%, whatever. If you got hung up on something, totally okay, tell me exactly where did you get hung up. Go. Fabulous. You guys talk to each other. What did you do right? What did you overlook? Good. Talk to each other. Huh? Yeah, then you get to boast a little. I got it right. Okay. Fabulous job, guys. You have 23 minutes to do a whopping 5 problems, folks. Go. You've got 23 minutes.
Is this length equal to that?
Of course it is. Yes. Nice job, guys. In 5 minutes, I'll open up a breakout room for page 3. You're guys at home, you're working on page 2 right now. And you guys in class are spaced out far enough, I can actually reach you. Okay? Yeah. You like to go for the most complex and work yourself backwards, that's fine. You okay? You do? Mr. Ross? I'm just seeing how you set that up. You're perfect. Area is always unit square. Area is always unit square. How we doing? Yeah, you good? Awesome. Yeah, just. Amelia has one. Is that handle on this?
Yeah, the same.
That would also be fun, right? Yes, ma'am. Absolutely. Thank you for actually tracing. This is good. Zach, you good okay? They are. Are you done with that last page already?
Yeah, I did it this time.
That's right. That's right. You are ahead. How you doing, Sophia? What have you figured out so far?
Well, these are congruent, so I assume that. they're like that half, so then the length would be 10.
You're correct.
But then that would mean that this height would be like 7.6.
Do me a favor. Can you trace from clover to clover? Or club to, no, clover to clover. See, there you go. Trace straight down. Straight down. Good. Trace, like with your pencil, trace here. Okay, straight from clover to, physically from clover to clover. What's that distance? Absolutely. Does that help you?
Right.
Edwin, you got a question there, sir? I'm good. You good? And that is times, that's correct, now. You good? Yes, ma'am.
What's the area for trapezoid?
Well, did you write it down?
I don't have anything.
I gave you a reference booklet here. So, Mr. Sanchez, did you write down all your reference booklet equations?
Yes, it is.
Okay, do you mind if McKenna borrows? Because your handwriting is out. Did you write everything down? Okay, put it there.
Because my handwriting is what?
Because your handwriting is more than no longer.
My handwriting never used to be good.
No, you obviously work on it a lot more than I do. RAGHT.
So can I go over the preview notes?
I'm just about to start helping people on page 3. So you're welcome to get your iPad out and start watching them if you'd like.
I don't have any earbuds, so. I understand.
No earbuds. If you want to go out in the hallway, you can.
I think I will take a break.
Or you can, do you have homework you can do from another class?
Probably biology.
I could probably double time. Let me see how many people want help with that particular page and then we'll go from there. Yes, dear.
Problem on 7, do you use Substitutions?
You could. What else could you use? You absolutely could use SOHCAHTOA. What else could you use? Students, if you would like help, I'm going to do some help on page 3. Some help on page 3. Send me a text. Help on page 3. Kelly, good question. Guess what? Do I specify, Kelly, which way to go?
No.
No, then you have a
Simple.
choice, kiddo. Yeah, you have a choice.
Okay, thank you.
So are you going to use the 30, 60, 90? You're going to use SOHCAHTOA?
I used, let me see. Where's it? I used 30, 60, 90.
Perfectly fine. Okay, Jonathan and Lua, please click the link. Hi there, Ryan. Hi there, Lua. Are you guys on page 3?
Not yet.
Not yet. Lua, are you on page 3? Okay, Ryan, what problem are you on? I'd like to help work with you.
I'm on 3.
This problem right here?
Yeah.
Okay. Lua, are you there, my dear? So I can chit chat with you. Okay, maybe she'll catch up. Okay, Ryan, how do you find area of a trapezoid?
It's base times height.
Kinda, except we have 2 different bases. So how do we handle that?
Oh, it's base plus base.
Yeah, we average the bases. Then we times by the height. Because, so it's kind of base times height. So you're right about that. It's kind of base times height. The problem is we have 2 different bases. And so we handle that by averaging. Does that make sense?
Yes.
Okay, great. So coming over here, could you physically trace one base? Do you see we're moving from -3 to +3?
Yes.
So what would that base be?
6.
Got it. So one of your bases is 6. What would your other base be? Yes, 11. So we're going to add, divide by 2. And then let's trace our height here, which is always straight down with the right angle. This time we're moving from this, which is 4, down to this, which is -1. So what would our heights be there? Ryan, what's your height there, sir? If I start
5.
and yes, it's 5. There you go. Take it from there, sir, okay?
Okay.
All right. I'll be right there. Jaden, what page are you on and do you need help? Edwin, what are you trying to do, buddy?
Just work it going off on me.
Okay, I'll bet. Jaden, what problem are you on? Do you need help? I am having people randomly drop out. Yeah, ma'am.
Is there any decimals?
Well, do you notice I said exact terms?
Yeah.
Okay, that's really important. That means absolutely, positively no decimals.
So we shouldn't be giving decimals.
Absolutely, positively not. So it kind of implies, what kind of triangle are you rocking there? Look very carefully. What kind of triangles are you rocking there? Here, let me highlight one for you. This guy. Yep. Well, not just a right triangle. Mr. Ross, I'll be right there, sir.
Oh,
30, 60, 90. Chant with me. 30, 60, 90. Short leg, root 3, short leg times 2. Again, 30, 60, 90. Short leg, root 3, short leg times 2. Make sense? Okay, so technically our 14 is here. Our short leg's going to be that red squiggle, correct? Okay, so red squiggle going to the long leg, what do we times by?
Can you say that again?
red squiggle, which is a short leg, going to the long leg, what do we times by? Short leg root 3. Yes, we do that. We do the long leg and then we do the hypo. And short leg to the hypo, we times by 2. Yes, ma'am. So it reads like this. Something times 2 is 14. Yes, ma'am. And then what would this beast over here be? What would this be? 7 times what, ma'am? Yes. Innies and outies don't talk to each other. So it's just what? They don't talk to each other.
Oh, 7.
Exactly. I call them hateful neighbors. It's like, we'll be next to each other, but we're not talking. Got it? So this is 7 root 3. You were correct on that. And then you find your diagonals and take it from there. Mr. Ross, what page are you on? Where are you stuck? Are you, is that the kite? Is that the kite? Okay.
So I've got the
Is what?
I got 10.
Okay, so you found, because you did this, you found that each of these were 10, correct?
Yeah.
Which implies going this way is also 10, correct?
Yeah, I'm not sure because there's like a pretty big gap. I don't know.
How about this? Could you physically trace from clover to clover? Physically trace. This is the ultimate brain and hand problem. If you stare at it, you will not get it, guaranteed. Did you trace it?
Yeah.
Good. Tell me something that's true. Yeah, good. Okay. You're correct on that. So that's 3. Okay, now I'd like you to pinch that with your fingers. Pinch the 3. Now, where else in the diagram is that exact distance?
On the other little,
Describe it. If I go like that, where would it be? Those are diagonals, by the way. Yeah.
Would it be like the one, the halfway?
That's what I'm talking about. So that's 3. What makes your total diagonal to be what, sir?
6.
Bingo. What helped you figure this problem out? Yeah, what helped you figure the problem out?
Honestly, I just wasn't sure because there's like a gap.
Mhm.
I thought I wasn't completely sure.
Sure.
It was,
Okay. Okay. So you were halfway there?
Yeah.
Okay. Sounds good. Sounds good. Edwin, where you at, buddy? Okay. You come over there and check it out. Okay. Lua, is there a problem you'd like to do together? Lua, is there a problem you'd like to do together? Lua, I'm sending you a link to a breakout room. I'd like to chat real quick, okay? So Lua, can you click on the link, please? Lua, you rocking it? What kind of track? 30, so chat with me. 30, 60, 90. Short. No, it's root 3.
Or 3, sorry.
Short leg times 2.
Yeah.
Okay, so we have a 14 here. This would be your short leg. So it goes like this: short leg to the long leg times root 3, short leg to the hypo times by 2.
Okay. So,
What would your short leg have to be there?
so.
Bingo. Take it from there. Yes, yes, ma'am.
On this.
Yes,
Is the 6 and 12 these things or are they?
they're the diagonals, ma'am.
Okay.
Yeah, the first couple of problems are always meant to be like easy peasy.
Okay.
Just FYI. Zach, what's up?
We do 5.
Sure, we can kind of get started on 5.
I have the equation, but I don't. think
Yeah,
I-
you're like, what do I do with that 5? That's random. Do that. Let me do a share screen. So you're down here. Tell me what you have so far, sir.
So I have the equation is 75 meters squared is equal to 9 plus x divided by 2 times 5.
Exactly. 9 plus x divided by 2 times by 5. There's a couple things we can do here. Okay, obviously that 5 is kind of the game changer. So what's your first instinct with that 5? Just tell me what your first instinct is.
Divide it for both sides.
That's perfectly fine. So I could go like this. And how would your next line read?
15
Equals,
equals 9 plus x divided by 2.
yes. Okay, now I have a whole number and a fraction. So what do I do?
Oh, I didn't do that.
You can change, you can always turn the whole number into a fraction, right? And then you take it from there.
Yeah, I try to multiplying the 2 first and then
You can do that too.
dividing the 9.
No, not divide the 9 because there's a plus sign there. You're going to end up subtracting the 9. Do you see the difference?
Yeah.
Got it. Jonathan, can you unmute and tell me what problem you're on? You need help?
Thank you.
Okay. Lauren, how you doing, ma'am?
I'm good.
Okay. Hudson, question, sir?
I don't have any.
Jimmy, you doing okay?
Yeah.
All righty. Ryan, question, sir? Good deal. Edwin, what's up? You don't need to look at your phone. You don't need to look at your wrist. I like you focused here. So what's this length right here? So you're correct. What would this be? No, it's right here. It's the 30, 60, 90. So from here to here.
Oh,
where does
yeah,
it come
I
from?
do agree.
Okay, so what
Sorry,
was
three.
it? What is it?
Sorry, three.
Good. Now go like this, go all the way across. What would that length be?
That'd be 14 root 3.
Correct. And go now all the way down. What would that length be?
14.
Correct. So that's diagonal times diagonal over 2.
Okay.
Okay. How are you doing now? Are you using substitute or are you using 30, 60, 90?
3 equal, I will try. Can I use 3?
Where did that come from?
Oh, are we just saying what?
Okay, hang on. The 60 there is an angle, not a length. Do you see the little degree sign? That kind of changes things. Yeah, that changes. Could you stripe this, just stripe it? What kind of triangle you got wrapping there? A little bit more. Breaking into song. Like literally breaking out into song. We got it wrapping. 30, 60, 90. I'm waiting for you to chat, kiddo. 30, 60, 90. Short leg, root 3, short leg times 2. Right? So where's your short leg? Where? That's your long leg there. The short leg's always across the middle. That's your hypo. Where's your short leg? There's only, okay, can you physically trace all 3 sides? Okay, put a box there. So short leg to long leg, you do times by root 3. Short leg to hypo, you do times by 2. Move out. So it reads like this. Something times 2 is 22 McKenna. There you go. You doing okay?
Yeah.
Good. Huh? What's up? What do you notice?
They're all kites.
Excellent. Keep talking.
So their equation area over 2
Yeah.
and are these their diagonals?
Well, those are the can you trace the diagonals inside the kite? Trace the diagonals. That would be 1, or the other ones. You got it. So you obviously need those lines.
Oh,
Yeah,
okay.
take it from there. Hi.
Is it okay if I get a decimal for this triangle?
Decimals are always okay, except you got your 11 root 3 in the wrong place.
I do.
Yeah, well, it's 30, 69, short leg root 3, short leg times 2. So
Oh,
in this
attention,
triangle,
grade
where's your
school
short leg?
Please remember, this
That's
is
short
during
leg.
lunch.
So it reads like this.
Only one or
Something
two
times 2 is
students per
22.
people and please stand
See
line.
that? So you've got to rotate it.
Apart while waiting in line for food.
That changes
Enjoy
everything.
your lunch break.
That changes everything. Devin, did you want to finish?
Could I come in during lunch?
Excuse me?
Could I come in during lunch?
I have to record
Oh.
during lunch today, but I'll be here after school if you like, and I'll be here tomorrow morning.
I need to meet with my Spanish.
I totally get that.
I can come tomorrow morning.
That'd be great. Morning's good. Hudson, question? If you don't finish, it becomes homework, guys.
Okay.
Okay? And then you just turn it in on Class Kick.
I finished.
Good deal. All righty, guys. Bye.